Hi, so last time we were going through the nature um, of a quadratic with your missing term. We did 4 examples, and this time I want to do two of the trickier examples you can get. And really, this is actually the most common question that comes up. So the next videos will be questions from the textbook because these are the ones that tend to come up most often. So this time we've got solve where x is a real number. So negative 3x. I'm just going to write it in order because otherwise my head gets sore. Okay, so we're trying to solve this. Now, the only thing that's different here is we've got our negative in front. Now, you could at this point, if you wanted, you could say, right, I'm going to times through by negative 1. That'd be plus 2x. Take away 1 is less than 0. You could, that's your, don't forget your rule. If you multiply through or divide through by negative, the sign changes. You could do that. I think it's easier to forget that step and say, well, if I'm solving this, what it actually means I'm doing is I'm finding the roots and then sketching. I'm finding the roots and then I'm sketching. So if I'm finding the roots, I want to make that equal to 0 and I'm factorizing. And it's at this point I would then say, okay, I'll times through by negative 1. So that's plus 2x, take away 1 is equal to 0. That's much easier to me than changing the sign up here. Because this equation here, even though the signs are different, will have the same roots as that equation. So if you think about it, if say they're doing something like this, they're kind of like the inverse of each other. They will have the same roots, so it doesn't matter that those signs have changed. So I think that's an easier way to fix that. So just don't forget, if you've got a negative term here, I would change your sign in the root section. So now we're doing a slightly more difficult trinomial. So we're adding to this number and multiplying the negative 3 because it's the 3 times the negative 1 to give us that. So what are our factors of negative 3? We're thinking 3 and 1. So that would be plus 3x, take away x, take away 1. So all we're doing is rewriting the 2x as 3x take away x. Okay, 3 take away 1 is 2, adds to 2. And 3 times negative 1 will give us our negative 3. That's all we're doing there. Then we do our little break. So we break it in half, take our common factor. Then we copy the bracket over and we say, right, what do I have to times this bracket by to get back up here? Well, I have times by negative 1. Negative 1 times x is negative x. Negative 1 times 1, 1. Okay, and sorry, I keep writing your zeros. And then put your two brackets together. So 3x take away 1, x plus 1. All I've done is moved the 3x, the negative 1 together, and then I've just brought that bracket down. And that's you finished. X is equal to a third, and x is equal to negative 1. So that's the roots of the equation. So a slightly trickier one this time. They're not making you go through the b squared minus 4ac stuff with a missing term. They're challenging you more in your factorizing. And now we'll do our sketch. Okay, so I know the roots of the equation, so all I've got to do is draw in the roots. So we're at negative 1 and a third. So I've got negative 1, call that negative 1, and 1/3. Probably could give myself a bit more space. I'll give myself a tiny bit more space. There we go. That is the roots of this equation. So this, as you can see, is a sad curve. I'll draw a sad curve. Something like that, maybe. Okay. Now, when is this greater than 0? Well, it's greater than 0. Just change the colour for fun. In this section, isn't it? That's when it's greater than 0. Down here, all the way down to infinity, that's when it's less than 0. So for this, the values of x, so when x is less than 1/3, yeah, x is less than a third, it is greater than 0, but x has to be bigger than negative 1. So x is greater than negative 1. So it's encapsulated. X is between the negative 1 and a third. If it was asking for when it's less than 1, you'd be saying, okay, well, it's when x is less than negative 1. That's all those values there. Or it's when x is greater than a third. It's all these values, on and on and on. Okay, so that's your two different types of answer. And in our case, we're going with that one. Okay, negative 1 and a third. So that's about 5 minutes. Yeah, we'll try the same again. I'll just do this. I won't really talk much. I'm sure you'll be glad to hear. That's those of you that haven't muted me already. That's totally fine. So I'll just go through the same as the other one. So the easier factorize this one, isn't it? Add the multiply that. So I'm thinking 2. Oops, it's going to be take away 2. Yeah, there we go. So as the first part done, that's me got the roots. You're like, oh, silence didn't last long, did it? Draw them in. They still not got used to the pens and stuff. There's -3. There's +2. And this time, yep, we've got another sad curve, don't we? Another sad curve. I'll just draw it same as last. As good as I can draw that. And it's when is it greater than 0? Well, all these values here, that's greater than 0. All these values down here are less than 0. A less than sign, I promise. I'll be saying x is between 2. Oh, sorry. It's less than 0, sorry. Less than 0. So the less than 0 ones are these ones. So just like the opposite of last time. I'm saying that x is going to be greater than 2, or x is going to be less than -3. Greater than 2, all these values here, and less than 0, I mean less than all these values here. So -3, -4, -5, -6, etc. So that's quite a good example. Then that's the two different types of answer you can get. Slightly easier that one because the factorizing was a bit simpler. Okay, they're trying to catch out with the negatives. Don't change your negatives here. Change it when you get the 0. But just don't forget you're coming back to this curve. Nice one. So I think that's two good questions um, to know how to do, which is similar to this last series, just with a little kick with a negative. Okay.